This is the Unit 4, Lesson 4 video. This comes from Chapter 12, Section 4 out of the textbook, and this lesson is about the law of sines. There's two mathematical practices that we're going to focus on in this lesson. The first one is make sense of problems and persevere in solving them, and the second one is construct viable arguments and critique the reasoning of others. So previously to this lesson, we found side lengths and angle measures of right triangles, and in this lesson we're going to find the area of a triangle using two sides and an included angle. If you remember from geometry, that would be side, angle, side. And we're also going to use the law of sines to solve triangles, meaning to solve for any missing sides or missing angles from a given triangle. So the law of sines is something new that you're going to learn about in this lesson. The concept of solving a triangle, what that means, is something that's going to be discussed in this lesson. And the ambiguous case is also something that you're going to learn about and be discussed in this lesson. So our first key concept is on finding the area of a triangle. And back when you learned Algebra 1, probably even before then in elementary school at some point, you learned that the area of a triangle was 1/2 base times height. But that's a rather simplistic way of thinking about finding the area of a triangle, and it's really hard to do if you're not given the height of the triangle, if you're not sure how to find that. So this is called the law of sines, and it's a different way, or actually this is not the law of sines, it's just a different way to find the area of a triangle that's not a right triangle, just any old triangle, if you know two of the sides and an included angle. So like a side angle side from geometry. So there's three ways of thinking about this formula. All of them start similarly. They're all 1/2, and then the two sides that you know times the sine of the angle that's between those two sides. So if you know, for example, side B and side A, then angle C is between them, so it would be 1/2 B times A times sine C. If you know side B and side C, then angle A is between them, so it's 1/2 BC sine of angle A. If you know side C and side A, then angle B is between them, so that would be 1/2 AC times the sine of angle B. So we're going to apply that formula to the first example where we find the area of this triangle that we're given. So we see that side AC is 6 centimeters, side AB is 3 centimeters, and angle A is 25 degrees. So essentially what we're going to do here is just multiply the two sides we know times the sine of the angle 25 degrees. And then multiply that by 1/2. When we do that, just plugging it all in the calculator, you get about 3.8. So the area of this triangle is 3.8 units squared. Oh, centimeters, not units, centimeters, because they obviously have centimeters here on this triangle. Okay, we're going to look at it. Check your progress problem. It says find the area of triangle ABC to the nearest tenth. Again, write this problem down on your sheet of paper for classwork. Show your work and pick your answer from these answer choices here. I'm not going to be displaying the answer choice on the screen. We've got the key concept for the law of sines. And this says, in triangle ABC, if the sides with lengths A, B, and C are opposite angles with measures angle A, angle B, and angle C, respectively, then the following is true. The sine of this angle A divided by side A is equal to the sine of angle B divided by side B, which is also equal to the sine of angle C divided by side C. So the purpose of this law of sines is if you know an angle and the side opposite it, and you know any other side or any other angle, you'll be able to solve for all the missing pieces within the triangle. So for this triangle in example 2, it says we need to solve triangle ABC, which means we need to find all the missing sides and all the missing angles. We're given in this triangle the measurements of two angles, and we're given the measurement of one side. So the first thing we're going to do is find the missing third angle, which should be pretty obvious because you know that the angles of a triangle always add up to 180. And since you're given two of them, you can just subtract the sum of those two from 180 and you'll get that the third angle is 27 degrees. And once we have all the angles solved, we're going to use the law of sines to find the missing sides. So to find side A, we're going to do the sine of angle A, which was 27, divided by side A. And then what we're going to set that equal to is the pair of angle and side that you know both of. So we know both angle B and side B. We don't know both angle C and side C yet, so we're not going to use that. We're going to use the two things that we know. So the sine of A over side A is equal to the sine of B over side B. Angle B is 53 degrees and side B was 9, so we're going to take this relationship. We're going to cross multiply and solve for A. When you do that, you will end up with the expression 9 sine 27 divided by sine 53. Plug that in your calculator and you're going to get that A is about 5.1 units long. And then we're going to do a similar process for solving for side C. So we're saying the stuff that we know, sine of 53 over 9, is equal to the sine of angle C over side C, which we don't know. So again, we're going to cross multiply and solve for C. When we do that, we'll end up with 9 sine 100 divided by sine 53, and that gives us a side C length of 11.1. So to solve the triangle, we have found that angle A is 27 degrees, side A is 5.1 units, and side C is 11.1 units. So we've got a check your progress problem now. We're going to solve triangle ABC here. Notice we have one missing angle and two missing sides. So I'm not going to display the answer on the screen again. Just do the work on your sheet of paper for your classwork. Pick your answer choice from the answer choices available up here. Okay, another key concept. This is for possible triangles that could be created when you were given a side, and an angle. So the SSA case. If you can remember that from geometry, side-side angle, your teacher will probably tell you never write this as angle side-side for obvious reasons. So we're going to look at triangles in which we know side A, side B, and angle A. So the cases where angle A could be an acute angle, you could look, the triangle could look like this. If A is less than the height, then there's no solution. You can't make a triangle that way. If A is equal to the height, there's only one possible triangle that could be made. If A is more than H but less than side B, you're not really sure what could happen because it could be in here, you could have this triangle, or it could be out here and have this triangle, so that you don't really know what to do. And if A is greater than or equal to B, then it's always going to be drawn out this way, and there's only one possible triangle that can be made. Case where angle A is a right angle or an obtuse angle, if side A is shorter than side B, then you can't make a triangle, and if side A is larger than side B, then you would sketch a triangle in this manner. Well, there's only one possible case for the triangle to look like. So for example 3, it says determine whether triangle NPQ has no solution, one solution, or two solutions, and then solve the triangle. Round side lengths to the nearest tenth and angle measures to the nearest degree. So they're giving us that side NP is 11, side QP is 8, and angle Q is 110 degrees. So we're looking at angle Q here, because this angle that we've been given. Because we're looking at angle Q, and angle Q is obtuse, and side 11 is bigger than side 8, you know that there's only going to be one solution. So we're going to use the law of sines. We know that sine of 110 over 11, those are the angle and the side pair that we were given. If you look here, we have angle 110, so sine of 110 over 11 is going to equal the sine of angle N over side 8. And so when we cross multiply that property right here and solve for sine n, we get that sine n is about 0.6834. So then we're going to do n is sine inverse, using the sine inverse function of 0.6834, and that will give us 43 degrees. So once we know that angle n is 43 degrees, and we already were given the 110 degree, we can use, just add those together and subtract from 180 to figure out that the last angle, P, is 27 degrees. And then we're using the law of sines to find side P. So we have this property, sine of 27 degrees over side P is equal to the sine of 110 over side 11. Cross multiply and solve for P, and that gives us side P is about 5.3. So our final answer, we have n is about 43 degrees, P is about 27 degrees, angle P is about 27 degrees, and side P is about 5.3 units. Okay, part B says determine whether triangle DEF has no solution, one solution, or two solutions. Then solve the triangle. Round side lengths to the nearest tenth and angle measures to the nearest degree. In triangle DEF, angle E is 52 degrees, side E is 5, and side F is 9. So we have to find how do we make this angle. It looks to me here, since this is acute and this side is shorter than that, there's not going to be any solution. We can't make a triangle in this manner. And so what they did here was they found H, not sure what H is, compared it to E. So they set up this expression. You get 7.1, 5 is less than that, so E is less than H, there's no solution. You can pretty much just come back here and look at this. We're finding the height. If we find the height of this triangle, that would be the side that's opposite 52, this imaginary triangle right here, and the hypotenuse. So the sine of 52 would equal h over 9. Solving for h, that would be 9 sine 52. That's what they did here. That's 7.1. So since this height of 7.1 is greater than this side, you can't make a triangle. Or you can similarly think about it as, since this side is shorter than the height, there's no possible triangle that can be made from this scenario. Part C now. Determine whether triangle XYZ has no solution, one solution, or two solutions. Then solve the triangle, round the side lengths to the nearest tenth, and angle measures to the nearest degree. Angle X is 28 degrees, side Z is 15, side X is 9. So again, we're going to find the height here. The sine of 28 is going to be h over 15. Let me write that on here. That's going to, when we solve that for h, it's going to say h is 15 sine of 28. And when we put that in our calculator, that's going to tell us that h is about 15 sine 28 is 4.1 about. And since this height is less than this side, that means this triangle is possible. So we're going to pick up in the next video to figure out the rest of this problem.